Okay, I'm going to answer the ones from Thursday and then move into a new little thing. We're going to get off integers for just a little while. Some of you guys may be excited about that. I did grade your test. I will be posting the answers after the Friday deadline. You know, our school deadline is if you miss a test, you have until the following Friday to make it up. And so there's some tests still out. So as soon as all those make it in, I will post the answers to the test so that you can go through and check and see which ones you missed. So anyway, let me answer these ones from Thursday though. So these are all multiplication or division. So this because there's no signs in between the two parentheses or in between the number and parentheses. So they are multiplication, and the ones written as fractions are division. So positive times a negative is negative. So negative 21. Negative 8. Same thing with division. If one of them's positive, one of them's negative, the whole thing's negative. Okay. Negative times a negative is positive. Okay, same thing with division. A negative divided by a negative is positive. One of each, the whole thing's negative. So negative 7. Positive 14. This one I put to show you, if there is that dot, that multiplication, it is a multiplication, but we just don't write that dot. It starts to look like this. We don't need the dot, so we put it like that. So 5 times negative 2 is negative 10. Negative 12 here. And then this one I had you do a 3, 1. 6 times negative 2 is negative 12. Okay, and so we just did 6 times negative 2, which is negative 12, positive times a negative. And then a negative times a positive is also negative. So negative 48. Okay? So those are those ones from Thursday, and that way you can check your answers. I'm not going to spend really a lot of time. We'll do some on the study guide, but those are, like I said, the rules are easy. It's just kind of identifying them. What I want to look at today is this new thing as far as on this unit, kind of getting off integers, but it will be on this unit, and that is some exponent rules, okay, and what to do with exponents. Now, exponents, you may have seen them before. You may have remembered them, but you may also maybe haven't seen that much of them. So an exponent is basically like when you see this number, like let's do 2 to the third power, okay? That's that little number they write up above here, okay? Now, one thing about it is, you can have it there. It can be 2 to the second power. It can also be the same number. It could be 4 to the third power or something. It's those little powers that are up here, written up. One thing about them is they're not written down below. Okay, later you're going to see problems that there'll be numbers written down below. That is not an exponent, and it's mainly in formulas like this. Okay, you may see something like that. This is not an exponent. The exponent is going to be written above. Okay, so it's not these. Okay. Now, another thing about them is they're not multiplication. That's the biggest mistake I see. It's not 2 times 3. If we were going to write 2 times 3, we would write it like that. Okay, just like we just did with the multiplication. Okay, so it is not 2 times 3. That's the biggest mistake I see. Sometimes it comes out to the same answer very few times, but it could. But this is not 2 times 3. It's 2 times 2 times 2. Okay, it's 2 multiplied by itself 3 times. Okay, you can square anything, or you can take anything and make it an exponent. I do a joke in class that you could do potato, and you could square it, and that means potato times potato. And you say, well, why? Like, when are you going to ever square, and we do this big joke about it, but when are you ever going to square a word? Well, You do it with measurements, like if I said, something is 4 feet square. Okay, I'm squaring not the 4, I'm squaring the feet. Okay, so it's 4 foot by 4 foot by 4 foot by 4 foot. I'm squaring the feet. Okay, it's feet times feet. So you can square a word, you can square a letter. We're going to get, when we get into exponents that are variables, you're going to have like y to the third power, okay, which means y times y times y. Okay, so that is where you can use an exponent on a letter, on a word. So it doesn't just have to be on a number. So it's 2 to however many power this is. We use that term squared. That's when it's to the second power, and we use cubed for to the third power. Everything after that we say to the fourth power, to the fifth power, to the sixth power. So keep that in mind. That's going to be squared, that's going to be cubed, and then everything after that is fourth power, fifth power, sixth power. So 2 to the second power, or 2 squared, is 2 times 2. And then 4 cubed is going to be 4 times 4 times 4. Okay, so that's what those are. Then you go ahead and do the math of it. 2 times 2 is 4, times 2 is 8. So see, it's not 2 times 3, it's not 6. It's 2 times 2 times 2, which is 8. This one happens to be the same whether you do that or not, but it's 2 times 2, which is 4. And then this is 4 times 4 times 4, which is 16 times 4, okay, which is 64. So that's how you work those exponents. A couple special exponents is something to the first power. Like if you have something to the first power, it just is itself. So 256 to the first power is 256. Okay, because you're just, you're taking it to the first power. You're not multiplying it by anything. Something to the 0 power. So 7 to the 0 power, or 3020, or 3264 to the 0 power. Okay, that answer is always going to be 1. Doesn't matter how big the number is, anything to the 0 power is 1. So I basically gave you a test answer there, so don't forget that one. If you see something on the test that says something to the 0 power, you don't have to do any math, you just answer with 1, okay? There's a whole explanation for that we can do later when we're on variables with exponents, but that is one of the things I wanted to show you with that, okay? Now, so those are how you work an exponent. You just take the number and you multiply it times that many times itself, okay? And so those problems, you'll get a little practice with them, multiplying and getting those answers. We're gonna later see, and I wanna go ahead and introduce, even though I usually don't do variables and letters until we actually introduce letters into it. I want to just use a letter to show you the rules of exponents, okay? So don't freak out that I'm using X's and Y's, okay? I want to just show you what we do with that, okay, with the exponents. I could use numbers, but it gets a little tricky when you first see it, so I want to start with like a letter. So let's just talk about, and see, when I introduce variables, as far as without exponents, we just talk about what X is and Y is. I go through the long reason of why we use letters. So I know that's one of the biggest things I hear on the street when I talk to people about math. Not that I talk to a lot of people about math, but that's one of the things I always hear is, why do they put letters in? Well, we do have a good reason. So I'll go through that once we use them more in the problems of letters. What I want to do here is just show you, I just want to show you the rules of exponents, and I think it's just easier to use a letter to show that. So first off, let's say I have x cubed, okay? Now remember, I could square potato, I could square feet, I could cube feet, I could cube potato. So all this means is I'm taking x and I'm multiplying it by itself 3 times, okay? So right now we don't even need to know what x is, we don't even need to go through it. We're just saying we're taking this letter and we're cubing it, okay? And let's say I want to multiply that by x to the fourth. Okay, I want to take this x cubed, which is this, and I'm going to parentheses so you can see this is what this is. And so that's x times x times x. And then I want to multiply that, so I'm still multiplying here, by x to the fourth, which x to the fourth is x times x times x times x, right? That's x to the fourth. Okay, so x times cubed is that, x to the fourth. Well, now they all are just multiplied by each other. Okay, because with multiplication, you just go left to right. So I could go x, there's times itself, times itself, times itself, times itself. So how many times am I multiplying x times itself? Well, 1, 2, 3, 4, 5, 6, 7. So x to the seventh is what this is. Well, if you notice, how did I get 7? What's a shortcut for that? I just added 3 and 4. X to the seventh. Okay? Let's do a different letter just to show you it doesn't matter what the letter is. Let's do y squared times y squared. Well, my shortcut's going to tell me that that should be y to the fourth. Okay, just add 2 and 2, you get y to the fourth. So let's check it out. Y squared is y times y times itself, times y, which is y times 1, 2, 3, 4, y to the fourth. Okay? So when you're multiplying two things, you could take this same, we call this a base. You keep the same base, and you just add the powers, add the exponents, okay? Well, let's use numbers now. That's why I didn't want to start with numbers, but I want to show you we're doing the same thing. So let's say I take 4 to the third times 4 to the fifth, okay? Well, let's do the same thing we did here and do it here. Keep the same base. What's the base in this case? Not x, it's 4. So keep that 4 and just add these exponents, and it's to the 8th. Okay, and let me check that out and see if that's true. 4 times 4 times 4 is what that is, times 4 times 4 times 4 times 4 times 4. That's 4 to the fifth, right? 1, 2, 3, 4, 5. So add them all up. 1, 2, 3, 4, 5, 6, 7, 8. It's 4 to the 8th. Okay? So that is how you can do it with bases, and whether it's a letter or a number, that rule stays the same. Okay, so let's do one, show you like, it doesn't matter how big the number is, 20 to the third times 20 to the fifth. Now, I'm not actually gonna, or let's do, I know it ends up being the same as that, but that means you keep the base the same, 20, and you add the exponents, 20 to the 8th. Now, I'm not going to do that because it's going to be huge on the calculator. In fact, I don't even think a calculator could hold it. But it'd be 20 times 20, 8 times. Okay? So it would just go on and it'd be a huge, huge number. When things grow exponentially, they grow much faster than just multiplying it times, 20. Like you could do 20 times 8 and it's 160. You do this, 20 times 20, 8 times, and it's going to be a huge number, okay? So that's just the basic parts of the exponent rules. I'm going to give you some problems here for your assignment, okay? What I want you to do is find the answer, so I'm not going to make them that big of 20. I just want to show you it doesn't matter how big the base is. But let's see, I want you to do 4 to the third power, 3 to the fourth power, okay, 2 to the, let's do fourth power. Let's do 5 to the third power. And you can use your calculator. I don't mind. It's just getting practice. So you do 4 times 4 times 4, or 5 times 5 times 5. Okay, so that's fine. I don't mind if you use your calculator. Calculators, I'll show you later, some scientific calculators have exponent buttons. I think sometimes just putting them in manually can be just as easy. So just putting in 5 times 5 times 5, okay. Let's do 5 to the 4th power. Okay, and then I'm going to have you do a couple of these letter ones. X to the 3rd times x to the 6th. Y to the 5th times y squared. And then I'm going to have you do a couple number ones. So let's do 9 squared times 9 squared. And then let's do, let's see, keep it smaller, 2 to the 3rd times 2 to the 4th. And then throw a little tricky one on you here at the end. Let's do 5 to the 3rd times 5 to the 1st, okay? And see what you come up with that, okay? So those are your assignments from this. With these, so answer these to what they are. These obviously you're going to have just still x and y, and then you'll answer these, okay? All right.